So now we are going to discuss very important problem. So here read that problem. The distance between identical balls having unlike charges is 2 centimeters. The radii of the balls are much less than distance between them. That means they are very small balls. The balls attract each other with a force of 36 into 10 to the power of minus 5 newtons. They are attract each other. That means they are oppositely charged. We know that from the properties of charges, opposite charges are attract each other. After the balls have been connected by a wire, that means whenever these balls are connected by a wire, the latter has been removed, the balls repel each other with a force of 20.25 to the power of minus 5 newtons. That means whenever they are connected by a wire, they share the total charge equally. That is very important. Here this is the important line. Connected by a wire, whenever these two charged balls connected by a wire, there is a sharing of charges between the two balls. That sharing is equally. That means they share charges, total charge equally. Then in that case, they repel each other with a force 20.25 to the power of minus 5 newtons. Okay? Determine the original charge on the balls. Very important, different model on the Coulomb's law. Now we are going to solve this problem. Right. Here the radii of the balls are much less than the distance between them, means they are very small balls. These are the two balls. They are separated by a distance how much? 2 centimeters. So let us assume the charge present on the first ball is Q1. Now what is the charge present on the second ball? Definitely that is minus charge, negative charge, that is Q2. Why? Because they are attract each other. They are attract each other with a force of 36 into the power of minus 5 newtons. Right. So from this information we write equation F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. R means what here? 2 centimeters. R square 2 into 10 to the power of minus 2 whole square. Here we need not to put a negative sign here. This is a force. Okay. Force is a vector, so no need to write a sign. Right. Here what they given? F is equal to 36 into 10 to the power of minus 5 is equal to that is equal to here 1 by 4 pi epsilon naught Q1 Q2 divided by 2 into 10 power minus 2 whole square. Okay. Why we write like that? This is in centimeters. We should convert into meters. Equation 1. Now, these two charges are connected by a wire. These two balls are connected by a wire and separated in the same distance. These are connected by a wire. This is a wire. So whenever these two charges are two charged balls are connected by a wire, they share charges equally. That means the charge present on the first ball is Q1 minus Q2 by 2. The charge present on the second ball is Q1 minus Q2 by 2. They share the charge equally. Now these two charged balls repel with a force of how much? 20.25 to the power of minus 5. That is equal to F is equal to 1 by 4 pi epsilon naught q1 minus q2 by 2, q1 minus q2 by 2 by r square is equal to how much? 2 into 10 to the power of minus 2 whole square. Here what? F, repulsion force, 20.25 into 10 power minus 5 is equal to 1 by 4 pi epsilon naught. What we get here? q1 minus q2 whole square divided by 4 into 10 to the power of minus 4. So this is equation, let us assume as 2. Okay. Now from this equation we write q1 minus q2 whole square is equal to, here 1 by 4 epsilon naught is equal to how much? 9 10 to the power of 9. So bring this term to this side, 20.25 into 10 to the power of minus 5 into, okay, 4 into 4 is equal to how much? 16. 16 into 10 to the power of minus 4 whole divided by 9 into 10 power 9. 9 10 power 9. Now q1 minus q2 is equal to, so here q1 minus q2 is equal to square root of 20.25 into, right. So here write direct step, 10 to the power of minus 5, 10 to the power of minus 4, 10 to the power of minus 9, 10 to the power of 9 here is in denominator. So bring this 10 to the power of 9 to the numerator. That means we write here 10 to the power of minus 9. That means 10 to the power of minus 18. 10 to the power of minus 18 written as 10 to the power of minus 9 whole square. Square root cancel. Right, into 16. What is the square root of 16? That is equal to 4. By what is the square root of 9? 3. Square root of 9 is 3. Right. Now here q1 minus q2 is equal to, q1 minus q2 is equal to square root of 20.25, nearly 4.5, nearly 4.5. So 4.5 into 4 into 10 power minus 9 divided by 3, that is equal to, here q1 minus q2 is equal to, what we write here, q1 minus q2 is equal to 4 into 4.45, 18 into 10 power minus 9 divided by 3, that is equal to q1 minus q2 is equal to 6 into 10 to the power of minus 9. Okay, this is assumed as 2. Right. Here from 1, what we write q1 q2 here, from 1, so q1 q2 is equal to, here 36 into 10 to the power of minus 5 into, okay, 2 whole square 4, 10 to the power 4 into 10 to the power of minus 4, 4 into 10 to the power of minus 4. Here 1 by 4 epsilon naught is equal to how much? 9 10 to the power of 9. So this will come to denominator, 9 into 10 power 9. 10 power 9. So here q1 q2 is equal to, This is 9 ones are 9 fours. So 4 into 4, that is equal how much? 16. 16 into 10 to the power of minus here 18. 10 to the power of minus 18. So this is equation 3. This is equation 3. Equation 3. Right. We know that we already find out q1 minus q2 is equal to 6 into the power of minus 9 q1 q2. We know that there is a mathematics formula q1 plus q2 whole square is equal to q1 minus q2 whole square plus 4 q1 q2. 4 q1 q2. Right. Now we find out q1 plus q2. q1 plus q2 whole square is equal to q1 minus q2 is whole square is equal to how much? 6 into 10 to the power of minus 9 here. That is equal to directly write whole square. That 6 square 36. 10 to the power of minus 9 whole square. 10 to the power of minus 18. Plus 4 into what is q1 q2 here? 16 10 to the power of minus 18. 16 into 10 to the power of minus 18. Right. So here q1 plus q2 whole square is equal to 36 into 10 power minus 18 plus 4 16 are 64. 64 into 10 to the power of minus 18. Right. So q1 plus q2 whole square is equal to, bring common 10 to the power of minus 18. That is equal to 36 plus 64 into 10 to the power of minus 18. Okay. q1 plus q2 is equal to how much? This is 100. What is the square root of 100? 10. 10 into 10 to the power of minus 18. 10 to the power of minus 18. This is equation how much? Fourth equation. Now we know that q1 minus q2 is equal to how much? 16 10 to the power of minus 9. Okay. q1 minus q2 is equal to 6 into 10 to the power of minus 9. We find out q1 plus q2 is equal to 10 into 10 to the power of minus 18. Solving this equation. Solve second and fourth equation. So we get here by adding these two equations. That means here q1 minus q2 is equal to 6 into 10 power minus 9. q1 plus q2 is equal to 10 into 10 to the power of, here we wrote this is 10 to the power of minus 9. Why? Because 10 to the power of minus 18 square root 10 to the power of minus 9. So 10 to the power of minus 9. So by adding these two equations, 2q1 is equal to how much? 16 10 to the power of minus 9. Okay. That means here that means here 2q1 is equal to 16 10 to the power of minus 9. That means q1 is equal to 8 into 10 to the power of minus 9 coulombs. 8 into 10 to the power of minus 9 coulombs. 8 into 10 to the power of minus 9. Now q2 is equal to how much? q2 is equal to, so here q1 plus q2 is equal to what we get here? 10 into 10 to the power of minus 9. Now substitute this value, 8 into 10 to the power of minus 9, okay, plus q2 is equal to 10 into 10 to the power of minus 9. That means q2 is equal to how much here? 10 into 10 to the power of minus 9 minus 8 into 10 to the power of minus 9. So q2 is equal to, we write 2 into 10 power minus 9 coulombs. So these are the answers. So finally we find out charge on the balls. Charge on the balls. What are these charges on the balls here? So here q1 is equal to how much? 18 10 to the power of minus 9. Q2 is equal to how much? Q2 is equal to 10 to the power of minus 9 coulombs. So this is the one important problem on the Coulomb's law. Okay, right.